This lesson shows some ways to draw a simple polygon. The dimensions of the polygons are shown in this diagram. A polygon is defined by points of inflection. That is, a polygon consists of a group of straight lines joining a set of points, and at the end of the last line, a connection is drawn back to the point at the beginning of the first line. Notice that some of the points in this polygon have negative values for x and y. That's because the polygon is drawn around the origin, the point 0, 0, which is its center. It's done this way because in the upcoming examples we're going to be moving it around the window, and it's easier to keep track of things in your mind if you know where it came from. This program displays the polygon in the place where it's defined. Now here we have two arrays named x and y that contain the points that define the polygon. Notice that these two arrays end with the same point with which they start. That way the program can just join all the points and close the polygon back to the beginning. That is, it connects the 8 points by drawing 7 line segments. Now this is the loop that draws the line segments of the polygon. This loop calls the draw line method once for each line segment. It draws a line from the first point to the second, then from the second to the third, and continues until it draws the last segment, which closes the polygon. The center of the polygon is at the origin, so we can't see it all. But it's easy to move. All that's necessary is to add the same value to each of the coordinate positions. Now, here's a program that does that. The paint method in this program is just like the previous one. The only difference is that each point is translated by having a value of 20 added to it. This moves every point drawn 20 pixels to the right and 20 pixels down. The translation of the coordinates makes the entire figure visible, like this. But there is a simpler way to draw a polygon. Instead of looping, you can do the whole thing with a simple single method call, like this. Here the loop is gone and replaced with a call to draw a polygon. Notice that there is one less point defined in the array. The last point, the one that was drawing back to the beginning, is no longer included at the end of this array. That's because the draw polygon method draws the last segment automatically to close the figure. But we've lost the translation of each point that moved the polygon into the screen. Here's a version that gives us that back. Now this sort of point translation is something that's built into the Graphics 2D class, so we will need to use the Graphics 2D object. This is the construction of an affine transform object. And this is a call to its set-to-translation method that instructs the affine transform object to add 20 to the x and y values of each point to be drawn. The affine transform is stored in the Graphics 2D object in much the same way that a color object is stored in there. This means that the transform will apply its rules to every pixel drawn in the window, whether it's a polygon or anything else. Here you can see that the affine transform has moved the drawing from its original location to the new location. There is lots more that can be done with affine transform objects, and we're going to be looking into that in the next few lessons.